Hey everyone, it's Colt. Hope you're all doing well. Today we're talking about the plethora of CSS units. We've got pixels and REMS and Ms and VHs, VWs, VMin, VMax, percentages, millimeters, inches, centimeters, points, Qs, whatever those are, and a whole bunch of others. In this video, I want to spend time talking about the most important modern CSS units and when you should use them and when you should avoid them. This video is part of a series I'm doing for beginners to learn how to code. Please consider subscribing if you're not already. I'm getting mightily close to 100,000 subscribers. I really appreciate it. Let's get the show on the road. Here we go. Units. Within the world of CSS units, there are two main camps, two groups. There are relative units like Ms and REMS or root Ms, VHs, VWs, percentages, all of which we use to define some length or size relative to another value. Versus absolute units like pixels and centimeters, inches, millimeters, there's even quarter millimeters, which are not as commonly used, definitely. In that group of absolute units are always fixed in size in relation to one another. So I'm going to focus more on relative units. Those are the more useful ones in my opinion, the more modern, more commonly seen. But we're going to start with absolute units just for a moment. By far the most common out of these absolute units are px or pixels, but as you saw in the previous slide, there are many other absolute units. This is the CSS specification, the standard, the document that outlines how CSS is supposed to work. There's a section on absolute lengths. We've got centimeters, millimeters, Qs, which are quarter millimeters, inches, picas, points, and pixels. Now, it's important to understand, if we take pixels as our first example, that a single pixel, 1 px, is not necessarily actually 1 pixel on your screen. In the past, that's how it was supposed to work, when there were more standardized displays and resolutions were pretty poor. But nowadays, we've got high resolution displays, you've got retina displays where the single space that used to be 1 pixel is now 2 or more pixels. So that is not how pixels, the unit, actually works. If you're curious how these are actually defined, how these absolute units are set, what their actual size is, the spec mentions that the dimensions are anchored either by relating the physical unit to their physical measurement or by relating the pixel unit to the reference pixel. So these other measurements, these units like millimeters, centimeters, inches, those are apparently often used in print. I don't have enough experience there to say if that's actually true, but allegedly that's what they're used for. So if you're using like a high resolution laser printer or something, it's the job of the printer or some software to make sure that 1 inch, the unit IN, equals 1 physical inch on the printed page. But in browsers, that's obviously a big issue with different screen resolutions. So 1 pixel unit is supposed to be set to something called a reference pixel. This is going way down a rabbit hole that really doesn't matter. But if you're curious, a reference pixel is supposed to be the visual angle of 1 pixel on a device with a pixel density of 96 dots per inch and a distance from the reader of an arm's length. Okay, so all this tells us is that a pixel in modern browsers is not necessarily a single actual pixel on the display, but these units are all absolute. So whatever that pixel is, an inch is going to have exactly 96 pixels in it. And then from there, you can see all the conversions here. All of these units can be derived from the size of that pixel that is set based off of that weird reference pixel size. Anyway, over here I've got a quick little demo. We see pixels a lot. I don't really recommend using them for font size. We'll talk about why. There are better units. But just as a quick demo, right, if we have an H1, or select all H1s, and to make the font size 80 pixels, and then somewhere else on this page I also reference 80 pixels, it should be exactly the same size. Let's make all H3s have a font size of 80 pixels as well, and those are the same font size. It doesn't matter where they are on the page, what they're nested inside of, these are absolute units. So if I instead did 96 pixels, which is supposed to be the exact same as 1 inch, and if I change that, we shouldn't notice any difference there. It looks exactly the same font size. 96 pixels versus 1 inch. Anyway, that's it. Pixels, millimeters, Qs, I've never ever seen those before. These are all absolute units, and generally these aren't as commonly used in today's world. Instead, we spend a lot more time with this side of the chart, I guess, the relative units. So there are quite a few here. We're going to start off with percentages. So percentages are what they sound like. They are a relative unit where we can define some size or a length that is a percentage of some other value. What's mildly confusing is what that other value is. It depends on the particular property that we're trying to set. So most commonly, I use percentages at times with width. If I'm trying to set a width of something, let's say I have 2 images, like I have here, and I want both of these images to be side by side, taking up 50% of the parent container space. So whatever that container is, they're in a section with the ID of gallery. So I could select that section, gallery, and give it a hard-coded width. How about 800 pixels? Maybe 1,000 pixels. And then I can use a percentage to set the width to be 50% for each image, which is 50% of the width of the parent. So let's just select all images here, and I'll set width to be 50%. Those are the only 2 images on the page. And there you go. You can see that they are side by side. If I add a border to my gallery, it'll be a little bit easier. Border, how about 3 pixels solid red? Okay, so that is my gallery there. They're each taking up 50%. If I added one more image in, we're going to have a problem, of course. Just duplicate that second image. Each one now takes up 50% of the width of this parent container. Why don't we do something like 33.333333 and see what we end up with? There we go. A third, and a third. So percentages in that context reference the parent element, whatever that parent element is. If I had my images not in the gallery, but instead just in the body, you'll see that they take up 33% or 33.33333% of the parent container, which is the body. Now, percentages work a little bit different with other properties. So for something like line height, if you set line height to be 50%, we are not saying 50% of the line height of the parent. We're saying 50% of the font size of the element itself. So the way that percentages work does vary. I mean, every single time it's just a percentage of some other value. But what that other value is can definitely vary, and it's best to look at the particular property you're trying to set and read the documentation. Okay, so what I'm going to do is take this H1 here, I'll give it a background color just for a moment so we can see the line height a bit better. Background color will be lavender with an E, and I'm going to change the line height to be 50% of 96, which is, what is half of 96? 45 plus 3, 48? Yes. So if I change this to be 48 pixels, it shouldn't look any different. And it doesn't. It's exactly the same. So in this case, line height, this percent sign, 100%, is 100% of the font size of this element itself. So that's percentages. Next up, we're going to move on to another relative unit, the M. And generally, this is pronounced M. The name M doesn't really mean anything in CSS. It allegedly comes from a typographical term back in the day. It's supposed to equal the width of the lowercase letter m. I'm pretty sure. It might be uppercase. But anyway, it doesn't actually stand for anything. M is another relative unit, and it's also one that is going to change how it behaves based off of the property that we're setting. So with font size, which is where M's are used a lot, 1M is going to equal the font size of the parent. So this is a relative unit. If I set something to have a font size of 2M's, it will be twice the font size of the parent, or 3M's, or 1.5M's, 0.5. A single M is the font size of the parent. So I'll show a quick demo of this. I've got this section right here. Let me scroll down here. I've got an H2, look at my stuff, H3, stuff. I'm going to get rid of some of this cluttering. And I'm going to select that. Stuff is my section. And I'll give it a font size, just the entire section of, how about 20 pixels. Okay, so now that I have that one font size set on this whole section, I can take H2s as an example and set font size to be 3M's, which is going to be 60 pixels, 3 times the parent element's font size. So here's our H2, 3 times that, 20 pixels is 60 pixels. If I just went with 60 pixels, it's exactly the same font size. Okay, so there's one example. Now let's do the H3 down below. I could set that to have a font size of 2M's. And that should be 40 pixels. Let's verify. It looks exactly the same. So these are another relative unit, right? And I'm taking that parent font size, whatever it is, and then tripling it or doubling it or halving it. Let's take the paragraphs in here and say that all paragraphs should have a font size of 0.5 ems. And that's pretty small. That is now 10 pixels. So I could do something like maybe 0.8 ems, or I could just go with 1 em, but that is a bit large, so I'm probably just going to go with 0.8 or something like that. So you can use ems for other properties, not just font size, but with those other properties, 1 em is equal to the computed font size of the element itself. So to demonstrate this, I'll work with this H2 that I have right here. And on this H2, I'm going to add a border so that we can just see a little bit clearer the width, or the height rather, of this element. Let's go with a 4 pixel solid, I don't know, let's mix it up. Let's do a dashed orange red. So we can get a rough visualization of the height of this element, which right now is not set explicitly. It's just based off of the content in there. But if I set the height to be, if I want it to match my font size, 3 EMs, what I'm actually doing is making it way larger, because in this case, with any other property that is not font size, 1 em is equal to the computed font size of the element itself. So what is the computed font size of this element? Well, right here, font size is 3 ems, and its parent element is a section that has a font size of 20 pixels. So we're taking 20 pixels times 3, which is 60 pixels. Then I'm saying I want 3 times that to be the height. What is 60 times 3? 180 pixels. So if I set this to be 180 pixels, nothing changes. To help me illustrate something else around ems, I have a new code pen here. It's very simple. It's just a nested, unordered list. So I've got some LIs and then some ULs and nested LIs, different things I'm hoping to find in the grocery store, some garden work, different tubers and bulbs. There's just some nested content. So I've got my section here, and there's an H1 and an LI. Let's say that I want the H1 to have a font size of maybe 2 EMs, maybe even 3. And then I decide, all right, if that's going to be the H1, I want my LIs to be a little bit larger, but not 3 Ms, maybe 1.5 Ms or something. So if I try that, font size 1.5 em. Okay, it's not terrible here. It's a bit large though. And then a little bit larger and larger. As you can see, things scale very quickly, at least when I have a number that is greater than 1. Now, if I wanted to shrink that down a bit, and I decided, you know what, I want 0.5 Ms, we're going to have the opposite problem. Things shrink down very, very quickly. And if for some reason I decided I wanted to give my ULs themselves a size as well, let's say that this is 1.5 Ms and ULs have a font size of 2 Ms. Oh dear, this gets large extremely quickly. Holy moly, that is a huge M. Literally M. Anyway, what's happening, of course, is that I have nested content. And I'm saying all LIs, if we just go back to this, let's do 2 Ms. It's a little easier to work with, or to do the math on. So we've got 2 Ms for every LI. So this is going to be twice the font size of whatever font size is inherited for this LI from its parent. And then same thing here. But then we get to this LI, and all of a sudden its font size, which was this thing's font size, is now being doubled. And then we get here, we're doubling again. And then we get to here, and it's another LI. So take that inherited font size and multiply it by 2. So this can be obnoxious in certain situations, or a lot of the time, I should say. Sometimes it's nice to be able to set a font size relative to the parent or the inherited font size. But a lot of the time, what I prefer and what most people prefer over Ms is root Ms, or REMs. RMs. I usually just say REMS. Anyway, REMs are root Ms, so they are a relative unit. However, they behave differently from regular old Ms because with REMs, everything is relative to the font size of the root HTML element. And this is often way easier to work with. Just as an example, if your root HTML element had a font size of 20 pixels, 1 rem is always 20 pixels. It doesn't matter where in the document you are. It doesn't matter if you're nested in a bunch of LIs like we have. It doesn't change. It's always some multiple or some value relative to the root element's font size. So I could use REMS here. If I know that I want my H1 and LIs to have a 2:3 ratio or 3:2 ratio in terms of font size, or maybe to make the math easier, let's do a 4:2. So I want my H1 to be twice as large as my LIs. If I use REMS, I can still achieve that, but I won't have to worry about this crazy nested insanity. Now, every LI is always twice the size of whatever the root element's font size is. And in most browsers, the root element, the HTML element's font size, defaults to 16 pixels. So REMS are nice because we can still have these relative font sizes where I don't have to use pixel values. I can say this is 4 times the root element font size, this is 2 times. I could say that, if we have some H2 in here, this H2 is going to just say to-do list, do this today, Colt. I can select that H2 and say that its font size is going to be 3 REMS. So 3 times the root element's font size. Or I can go smaller, 0.5 REMS. And just to show you, the default is usually 16. So if I change this to be 8 pixels, it shouldn't change in size. And it doesn't. It's identical, at least with the default HTML element font size. Usually, you're not going to go and directly change this. But if I did, and I say that the HTML font size is actually 30 pixels, everything is going to scale, at least everything that uses REMS. If I had something that was using pixels, it would not change. So if I make this smaller and I go to 10 pixels, everything shrinks down. So now this H1 is 40 pixels, 4 times 10. This is, 5 pixels? Is it half that? Yes, half of 10. So that's really the basic idea of REMS. They are going to allow you to define relative font sizes. And it's not just font size. You can use REMS for things like margin if you wanted to, or padding. But I find it most useful for font sizes because it does allow us to make responsive websites easier. If a user in their browser decides that they want a larger default font size, they want 20 pixels or 24 pixels as their font size for the HTML element. In Chrome and different browsers, you can change that setting. All of our text is going to scale appropriately. If for some reason I decide that I want everything to shrink down on my web page, or I want it to scale up, it's as simple as changing the HTML element's font size. So I personally prefer REMS, and most people do, but there are times where M's, non-roots M's, just regular old M's, can be nice. I'll show you an example very quickly. I've got a simple button here. It's not very attractive, and I'd like for it to have some rounded corners. So I'm going to set the border radius to be, how about 0.5 REMS? And there you go. You can see it has those rounded edges. I don't want it to be a circle or anything. I just want some curved corners there. And I'll add a little bit of padding. Padding will be 0.2 REMS maybe. Space it out a bit. Maybe a little bit more. 0.3. Sure. All right. So that looks okay enough, at least at that font size. But if I wanted this button to be able to scale in different situations, for example, if I take this button and I put it in my H1 right there, but I realize I actually want this button to grow to the same font size as its parent. So if it's in an H1, I want it to look larger than just this tiny little button. But if it's in a smaller LI or just on its own like it is here, I want it to be smaller. So maybe I won't use REMS. Maybe I'll use M's so that it does scale. I'll just set it to be 1 REM, so font size, or 1 M rather. And it now should just be the same font size as its parent. So that works, but then we have the problem that our curved edges and the padding is not scaling. Because no matter what the font size is in our button, we're setting it to have 0.5 rem border radius and 0.3 rem padding. That is not going to scale if the button itself scales. So this is a situation where we might want M's. So we'll still get those rounded corners. This is not a hard-coded number of pixels. Not that 0.5 rems is hard-coded either. This will change. The actual value will change depending on that root element's font size. But nothing is going to change based off of the button's font size itself. But if I just remove that R for padding and for border radius, now I have this button that has padding that is dynamic or is going to change based off of the font size of the button. So whether we have a very large button or a small button, we'll have the same level of rounded corners, the same roundedness relative to the font size. So it's not that EMs are useless and you should avoid them, not at all. It's just that I generally prefer using REMS until there's a situation where I know I want something to scale or to change sizes relative to other properties on that element or relative to the parent in the case of font size. Next up, we have two more units, VWs and VHs. They stand for view, technically it's viewport height and viewport width. And these are units that are relative to the width of the viewport or the height of the viewport, which is basically the dimensions of the browser window, the available space for that root HTML element. So in CodePen, at least, in my little rendered view down here, all the white stuff you can see is the viewport for this document. It's kind of confusing because it's embedded, right? This is an actual document too. Everything you see in this browser window is the initial containing block for the actual CodePen page. So if I shrink this down, let's focus on the white here. That's the viewport for the CodePen that I'm typing into. And as I change that and make it wider or skinnier or taller or shorter, the number of pixels available, you can see actually CodePen points it out, the size of the viewport changes. So VH and VW units are relative to those dimensions. So they go from 1 to 100. 100 VW is 100% the width of the viewport. 100 VH is 100% of the height. 1 VH would be 1% of the height, and so on. So let me illustrate an example of when this can be very useful. So if I have a section here, and I want to give this section a background that is a gradient. So I'll set background image, or just the shorthand background, to be a linear gradient. Let's go to right. From, I don't know, this is probably not going to be pretty, but from magenta to cyan. That's currently the size of the section. But if I want this section, I want that gradient to be the full height of the screen, I guess I could give it a height of just a number of pixels that I figure out, something like, I'm just making this up, but 500 pixels. And that kind of works, I guess. It's covering most of the screen. If I get rid of the margin and padding on everything, I'm just going to do that with the star selector here. Okay. So now we have this effect where it's 500 pixels tall, this big gradient, but it's hard-coded at 500 pixels. So if my screen shrinks down, I now have a lot of extra space here. And maybe the effect I want is a full height backdrop, like I have here, where there's different sections. So maybe another full height here, and then another full height, if that makes sense. These are all the same color, but I might want different sections that take up the entire height of the screen that you can see at any point, and then another section and another section. With what I'm doing here, I'm hard coding that in. It just doesn't work very well. But if I use 100 VH, I'm telling this section to have a height of 100% of the viewport height. So whatever that viewport height is. So I can't scroll through this right now. There's no scroll bar. There's nothing else to see. This is it. It's the entire gradient. It's actually easier to see if I change this to a gradient from top to bottom. We can see cyan all the way down there. So now if I scale this down and make this skinnier like that, we still see the entire gradient, magenta all the way down to cyan. If I make it a lot bigger, or if I full screened it, magenta to cyan. If I look at it in full-ish page view, same thing, magenta all the way to cyan. So I could use this to add another section in. My first section, well, both of them are 100% of the view height. So whatever that view height is, we see that first gradient. Now I scroll down, and here's a second gradient. Same thing, 100% of the current view height. So if I scale that way down, there's my first one, here's my second one. Make this a lot larger. It takes up the entire screen that I can see, and same thing down here. Okay, so that's VH. If I change that, of course, to be 50 VH, they will split that height, whatever is available. It might be a couple thousand pixels on a huge monitor, or it might be, I don't know, 300, 400, 200, something really tiny. So it scales. Now to illustrate VW's, view width or viewport width, I've added 4 divs in, and I'll select all divs and just give them a hard-coded height, maybe 150 pixels. And then I'm going to select the first div with ID of 1 and give it a width of 100 VH, or VW rather, to begin with, and a background color of, what should we do here? How about red? Okay, and I think I'm going to shrink this down actually maybe to 50 pixels. All right, so that's 100 VW. It's always 100% of the viewport width, whatever that is. So there's no scrolling involved here. This is the entire div. it's always taking up that available width. Now I'm going to do the same thing, but for the second div, and I'll set it to be 80 VW. I'll give it a different color. How about orange? And now it's always 80% of that viewport width. Let's say that I have one more. I guess I'll limit this to 3 probably. So let's do our third div and set that to be 50 VWs. I'll get rid of that fourth div and give it a color of yellow. It's always going to be 50% of that available viewport width. So things scale, and this can be super useful when you're designing responsive websites, which for the record is a topic I will be teaching shortly on this channel. If we had some nested content, let's say inside of this div with ID of 3, I have 2 divs in there inside of this third div, nested 1 and nested 2. So I'm going to select nested 1, and maybe I want to split this up 50-50. If I tried to use VWs, it would not go very well for me. So let's give this a smaller height. Let's do 50% height of the parent. Okay, so that works well. I get half that height. And then if I use VWs for width, I am not going to get anything relative to this parent. So I have to know exactly the width of that parent, which is 50 VWs. So if I wanted this to be half of that, it would be 25 VWs, which can be annoying to use and to have to calculate and divide things and whatever. It will scale, right? And it's always going to be half of this, which is half of the entire viewport width, but it's much easier in my opinion just to use percentages. I could say I want this thing to be 50% the width of its parent, and we get the same thing. And now I've added some styles in for the second div, and I can also give it a width of 50%, which is easier when you're trying to split up space, whether it's even or not. You know, maybe I want it to be a 20-80% split. It doesn't matter what the dimensions are of the parent or what the viewport is. So I can use VW or VH to set some larger container, which is what I usually do, like to make these sections here. But then within them, I'll often use percentages or some other unit for smaller pieces or for divvying up the space more. So that's it for the units I'm going to show in this video. There still are others that we have not discussed, but these are by far the most common. And something you might be thinking at this point is, which one should I use when? So these are just general guidelines that I like to follow. They're not rigid, and there's a lot of flexibility, and different companies, different developers have different preferences. In general, I avoid using pixels for font sizes, except when I'm just teaching the very basics, because pixels are easy to grasp, and I don't know, not having to explain REMS and EMS is nice early on. But generally, I don't use them for font sizes. They don't scale. Browsers these days can zoom and increase your font size. So, you know, if I had a pixel value, which I don't, but if my H1 was set with a pixel value, like how about 100px, as I zoom in and out here, the browser is able to scale that for me, but with older browsers, that actually wasn't a thing. But if you want your text to be responsive to the point where you can change all the fonts, you can multiply them by 2 or cut them in half or change them somehow relative to one another, using pixels is not a good way to go. However, I do often use pixels for small details, like the width of a border, usually the width of a box shadow or a border. If it's a couple pixels, you're not going to scale that as your screen size changes or as some width changes. Usually that is going to stay the same, so I use pixels for borders, shadows, tiny details. REMS and EMS I like to use for font sizes and often for padding and margin. I prefer REMS, most people do, but there are situations where EMS make more sense or can make things easier for you, as I showed with this button where we have the border radius and padding set using EMS. And then percentages, I like to use for defining layouts, for defining widths of things, or heights even. If I wanted, 2 or 3 or 4 images sharing the space of some parent div or a section, or I want my links in a nav bar to take up some percentage of that nav bar, I personally like using percentages. And then for larger layout concerns, like we just discussed, I like VH and VW. If you're trying to make a full size background, or you're trying to make something full width, and you want it to scale, you don't want to hard code a pixel value, which you shouldn't, VHs and VWs are a good choice. So I know this has been a lot, and maybe not the sexiest video in CSS, not that much is, maybe like animations or something, but this stuff is very important. Alrighty, so thanks for watching everyone. The good news is, now that we've covered units and all these crazy different options, we can now learn Flexbox, which is a very powerful, important piece of creating layouts in CSS. So in the next few days, look out for a video on Flexbox. That's definitely a flashier, maybe a sexier topic than units, but units are core to pretty much everything you'll do in CSS. So hopefully you made it through this. You didn't fall asleep. If you did, I hope you had a nice nap and my voice was soothing enough. I doubt it. I hate listening to my voice, but maybe it was nice and soothing and relaxing for you. Please consider sharing this video, but especially please consider sharing this entire playlist, all this Colt's Code Camp stuff. Share it with anyone you know who might be interested, anyone who's stuck at home, recently unemployed. I really, really appreciate it. I'm trying to keep this going. It is kind of a lot of work, honestly. Each one of these videos is pretty much a full day of me working on the video and doing nothing else. I enjoy doing it, but I do really appreciate you sharing this with anyone. And I hope you're all staying healthy, sane, safe. Wash your hands, of course. And I'll see you soon in the next video, which will be on CSS Flexbox. All right, goodbye.